Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you all back to school, and this is video made specially for grade 9 elite students. So let's start the video and see what we are learning today. So in today's session, we are covering from chapter 1 integrated to module 3 similarity, the first lesson, which is module 3 lesson 1 dilations. And this is Ms. Ruchika welcoming you to the session. Today is 30th of August and we are starting with our first lesson of term 1. So welcome all of you and let's dive into the video. Today's video is going to be pretty long, so I would request you to watch it towards the end because we are going to be covering the entire chapter module 3 lesson 1 today, dilations, and our learning objectives would be to use scale factors to calculate the dimensions of dilated images and to represent dilations as functions and find the scale factors of dilation. So before we do this, let's do a starter activity. This is on Khan Academy. I'm going to be giving you 5 minutes for trying to answer this now. And it is called Identify Transformations. So let me go to this activity and show you how to solve one question. And then we'll go to the key concept for today. Okay, so this is the first question that we'll be trying together from the activity Identify Transformations on Khan Academy. What single transformation was applied to triangle A to get triangle B? So there are two triangles that you see here. I'll go down and show you them in the great detail along with the four options. So from A to B triangle, if you see carefully, which is smaller, which is bigger? So I'm going to write here now. Let me change the color. So from A to B, if you see, the transformation which is happening, A is a bigger triangle, B is a smaller triangle. So from A to B, if you see, the triangle is becoming smaller. So translation, rotation, reflection, dilation. So definitely this is reduction and the answer would be dilation. You can check your answer, go down, check, correct answer, so you can then move to the next question. Similarly, you will be doing this question. I would want you to now complete the activity as I have already shown you how to do it. So as you saw in the activity, we had the answer for dilation in the first question. So there are two types of dilation that you should know. One is enlargement, one is reduction. As the name suggests, in enlargement, the new image or the new object is bigger in size. So if you see the picture, FGH is the blue triangle and it is enlarged to the green triangle RTS. So it has become bigger. So such a transformation, such a dilation is called enlargement, where the image is larger or bigger than the original figure. Here the scale factor is greater than 1. So your value of k represents, alphabet K represents the scale factor, and this scale factor is more than 1 when it is enlargement. Similarly here, if you see, the scale factor is 3, so the side becomes 3 times the original. So that's why it is enlargement, as RST is bigger than FGH. Okay, next the opposite of that is reduction, where the size is reduced, that is the image is smaller than the original figure. Here the scale factor is between 0 and 1. So K will lie between 0 and 1 when it is a reduction. For example, if the scale factor is 1 divided by 4, it is reduction, and the new figure, the green one you see here, WXYZ, is smaller in size than ABCD. So that's why it is reduction. So these are the two types of dilation. Let's see what questions can come on this in the next slide. So very simple example taken from your math book. Example 1, identify a dilation and find its scale factor. So if you are moving from A to B, that means from blue to green. Blue is smaller, so it's definitely a reduction. And if you see the size to calculate the scale factor, 1, 2, 3, 4, 5, 6. 6 is the side length. 1, 2 and 3. 3 is the side length. So the scale factor would be new divided by old. That means new is 3, old is 6. So this is 1 by 2 or less than 1. Therefore, it is reduction. The size gets reduced. Or in the book, it is given in terms of vertices. You can do that also. And the scale factor in that case will also be the same. Let's do this one. So from A to B means from blue to green. As you can see, it has become bigger. B is larger, so it's enlargement. And if you see the side length, 1, 2, 3, 1, 2, 3, 4. So old, new over old, that means 4 over 3 is the scale factor. It is more than 1, so it is enlargement. Or you can count the vertices and then get the length. In that case also, scale factor will be 5. Now comes your classwork. I would want you to solve this in your notebook. Let's do 1A together and 1B would be your homework. So here from A to B, as you can see, it is enlargement. 1, 2, 3, 4, 5. 5 is the length here. 1, 2, 3, 4. 4 is the length here. So the scale factor would be new divided by old. So 5 divided by 4, which is more than 1, so it is enlargement. Similarly, for the second one, from A to B, it is reduction. 1 divided by 3. So this is how you solve the question. Now try this question yourself. From Q to Q bar, is it enlargement, is it reduction? Very easy. From blue to green, it is enlargement. It is becoming bigger. Find the scale factor of the dilation and x. So you need to find the scale factor. Now scale factor or k is new divided by old. So how much is the new length? If you see, this is one length, this is the same length, and it is 3 times the length. So new is 3 over 1. See this length. How do you know? If this length is, for example, y, then this is also y, this is also y, this is also y. So it is becoming 3 times. That's why scale factor is 3. And because it is more than 1, it is definitely an enlargement. Why enlargement? Because you can see that the green one is bigger in size than the blue one. Now you need to find x. X is equal to what? Now you see this length QC is given. Let's make another figure. QC is given 5. X is from this to this, and total length is 15. So if total is 15, this is 5. How much is x? Think. You will subtract. So it is equal to 15 minus 5, which is equal to 10. So that's how you get your correct answer. Very, very easy question. I hope the guided practice was clear to you and you have solved it with me in your notebook. Now we are moving to part 2 of the lesson, where the key concept is dilations on the coordinate plane. So if you look at dilations on the coordinate plane, means the xy plane, the x-axis, the y-axis. So on the xy plane, we have each point represented by a coordinate. So x comma y. Here is the x coordinate, the first one, and here is the y coordinate. So on the coordinate axis, on the xy plane, each coordinate is represented by a point, and to dilate a figure by a scale factor of k with respect to the center of dilation, we just do the multiplication of the coordinates by k. So if the coordinate is x comma y, it will become multiplied by x, kx and ky. So the rule is just to multiply by k. Always remember. So now we'll see an example how it is done. So for example, you have a quadrilateral JKLM, the blue one, and its coordinate are given JKLM. You need to graph the image of this after dilation with a scale factor k. So what is the value of k? 2.5. So each coordinate JKLM will be multiplied with k equal to 2.5. So new coordinate will be this. So it is minus 5 comma 10 for j prime, minus 5 comma minus 5 for k prime, minus 10 comma minus 5 for l prime, and minus 10 comma 5 for m prime. So the graph of jklm and its image is drawn here. So as you can see, because the scale factor is more than 1, it will be enlargement, and the new figure would be bigger than the old one. So this uh, J prime, K prime, L prime, M prime is bigger in size, the green one, as compared with the blue one. Let's now do a Khan Academy activity. So I'm going to take you for another 5 minutes onto the activity. I will do one question for you. The name of the activity is Dilations and Scale Factor. Here we need to find the scale factor. So let's solve it together. This is the question given to you. I'm doing one question from the activity dilation scale factor. You are given a pentagon here, A prime, B prime, C prime, D prime. Let me go down. And it is the image of the pentagon A, B, C, D under the dilation with a scale factor of 3 by 1. So the value of scale factor, let me write here for you. K is equal to 3 divided by 2. So because the scale factor is more than 1, we know it is enlargement, and because the image is given to you, that means the smaller one A, B, C, D will have a smaller size. What is the length segment of AE? Okay, so scale factor is new over old. That means it is A prime, E prime, the new length, divided by AE. So this is the definition of scale factor, and this is already given to you. How much is this? This is equal to 3 by 2. So from here you can easily find AE. For that we need AE prime. So 1, 2, 3, 4, 5, 6. This is 6. So 6 multiplied with 2 divided by 3 will be your answer. 6 multiplied with 2 divided by 3. So this is going to be 4. So the answer is going to be 4. You can also check your answer. Correct. Similarly, you can proceed to the next question. And now you may complete your activity. I'm going to give you 5 minutes for the same. And let's go back to the presentation. Okay, so I hope today's session was useful for you, and if it was, then I would want you to complete this exit sheet for another 5 minutes in your math notebook, and also revise today's class. I've provided you the answers to check and complete your homework. Until then, this is Ms. Ruchika signing off from today's session. If you found the video useful, give it a thumbs up. Don't forget to like, share, and subscribe to my channel, and see you in my next class. Bye, students.